Welcome to a special remix episode of Reimagined Energy. Here's a collection of conversations focused on electric vehicles, how they're evolving, what's holding us back, and what's possible if we get it right. You'll hear from past guests who are pushing the boundaries of EV technology, infrastructure, and policy. From wireless charging to local manufacturing, this episode brings together diverse voices shaping the electric future. Whether you're an EV owner, skeptic, or just EV curious, here's something here for you.
Now, what's always on drivers' minds these days is how to avoid sitting in traffic and especially idling. Gas prices are high, so how does good planning help reduce this?
Yes. So basically, again, when we talk about these, multimodal solutions, what we mean is, I can explain you with an example for yourself, for your audience and general public, is that when we say that don't use your car, we don't mean that don't use your car at all. What we mean is that, whenever it is possible, use other modes of transportation. So, for example, if you are making a short trip, which is within, say, 3 to 5 kilometers, we encourage people to use other modes other than cars. If possible, like, for example, if you are using a vehicle just for your daily commute, why not use public transit if it is available for you? Instead of driving your car and then, parking it somewhere where it is sitting for 7, 8, 9 hours. So there is no use of it. And then, it also cost not just the city or the public agency, but for the entire community, having such facilities and spaces available for parking. So basically, if you are using transit, you are not only saving energy, but you are also contributing in terms of making your community safe, and sustainable.
Right.
So those are the aspects. And again, when it comes to biking or walking, as you understand, school children or youth who are, college, university students, we encourage them, if possible, if it is if you are closer to your institutions, why not use bikes, or why not walk to your school? And there are, as you understand, many programs which address safe walk to school or safe bike to school programs. So we basically support them, we basically encourage them, and we also work on it as a mobility solution experts to develop and design such infrastructure which is friendly for all of them.
I'm going to throw you for a loop here and ask you, does it make a difference whether something is electric or what's fueling these advanced public transit systems, like whether it's diesel or gas or electric? Does it make a difference?
Right. So, as you know, most of the time, all these motorized vehicles, whether it is car or bus or any other vehicle, we used to use, gas or diesel. These are the sources of energy. But nowadays, as you see, that we are seeing electric cars. We are also now seeing more and more electric buses, and we are also going towards electric light rails. So all these these are advancements, technology advancements, and improvements in the overall transportation infrastructure, or the vehicle, or the equipment that we use. So basically, they are all again good for the environment. So basically, the idea is that if you are using the alternative fuel energy, which is electric these days, you can again, in terms of decreasing the greenhouse gases emissions, and then you are basically upgrading the community, the city, or the province, or the country, in terms of energy efficiency, and it is also giving you positive environmental results as well.
Nobody really knows what the battery chemistry of the future is going to be. There's it's kind of much like, so vehicles have changed from a mechanical device to being more of an electronic device, much like your cell phone. And it's just like, every year there's a new iteration of an iPhone that, has a better camera and a longer lasting battery and that sort of thing.
Bigger, better, faster. Yeah.
Yeah. So this is a real challenge with battery technology, right? Is that nobody really knows what the battery technology of the future is going to be. And if you're asking companies to commit, hundreds of millions of dollars to opening up a new mine to mine a particular critical mineral that's necessary for the batteries of today, but may not be necessary for the batteries of tomorrow, then you're in a situation where, you have stranded capital and you're putting a lot of time, money, and effort into something that may not be required. So there's a lot of uncertainty out there on a lot of fronts, and I think that's business always likes certainty, and it's some of these things are just disconcerting when others say vehicle manufacturers are going to have a hard enough time just building the vehicles, let alone worrying about all of the different pieces of the puzzle that need to be put in place to ensure this transition goes smoothly and towards electrification.
You had mentioned how China has the most capability of processing the minerals that go into the batteries.
Yeah.
What are some of your thoughts on that?
Well, I think that's because China, was an early adopter and really focused on the electrification of vehicles, sort of largely before anybody else did. They have a competitive advantage in that space now. They have all virtually, well, and in most cases, pick an item, whether it's processing, it's battery development, it's some of the raw materials. China is got the lion's share of the market, and I think that's why you're seeing, for instance, the United States respond in kind by sort of being a little bit behind the eight ball and recognizing that the future is going to be electric, and also recognizing that they don't have, they're sort of in the same position with China as they used to be with the OPEC countries as far as oil is concerned. So they don't want to be beholden to a foreign jurisdiction that may not be a friendly jurisdiction for all the batteries, battery components, all the processing of the minerals and all that sort of thing. So the United States and Canada as well, I think, have put a keen focus on trying to ensure that we're building out a lot of that, those mines, the critical minerals, processing capability in North America as such, so that they can be a little bit more masters of their own destiny with respect to the development and building of not only the batteries, but the vehicles themselves.
The infrastructure. We can't have a conversation about EVs and anything to do with roads, or even infrastructure isn't only about the highways. It's about the charging. It's about the ratios you had mentioned, the IEA, and something to do with California. Can you tell everyone a little bit about that side of things?
Sure. I mean, infrastructure is key, and I think the CAA actually sponsored our panel on Monday that I spoke at, and they released a report relatively recently, I think just a couple of weeks ago, that surveyed EV owners. And, EV owners were typically, saying they were really enjoyed their vehicles, were thrilled with their vehicles, would probably not go back to driving an internal combustion engine vehicle. But even, with as much as they liked their vehicles, they were still very concerned about the charging infrastructure. And, we've always said as an industry that charging infrastructure, it's a bit of a chicken and the egg issue, but the charging infrastructure really needs to be in place to provide consumers with the confidence that they can buy a vehicle and, just like a gasoline station, they can find a place relatively easy to charge it when they need to charge it. Because right now, it's still a situation where, you don't see signs on the side of the highway saying that, in most cases anyway, saying there's an EV charging station at the next exit, like you do gasoline signs. And it's really a situation too as well. How much is the right amount of infrastructure? And, from our perspective, you mentioned the International Energy Agency. I think their sort of benchmark is that jurisdictions should have, one sort of EV charging station for every 9 EVs on the road. I think Europe has a slightly different metric. I might get my numbers mixed up, but they're either 1 in 10 or 1 in 7, and California is either 1 in 7 or 1 in 10. I forget which is off the top of my head, but even if you look at California, it's a jurisdiction, much smaller than Canada is as a nation. Same number of vehicles on the road, but they're suggesting that even with their smaller geographic footprint, again, I forget the ratio, but it's either 7 to 1 or 10 to 1. And Canada, in terms of the analysis that Natural Resources Canada is undertaking to look at this, has suggested, we think 24 to 1 is the right ratio. And, we just, we have a hard time as an industry seeing how that could be possible, given that we're a much larger jurisdiction, a colder jurisdiction in the wintertime when there tends to be battery degradation. So, we believe we need a lot more than the 24 to 1 ratio that's been suggested in consultants' reports to the federal government. And one last thing I would say on it is that I think you almost need to overbuild the infrastructure at the front end to provide consumers with that confidence. Some of those stations ultimately may not be needed and could potentially be decommissioned. You don't want to put in infrastructure needlessly, but if we really want to encourage consumer adoption, then consumers need to know that they can charge their vehicle wherever. And for people that live in a detached home and have a garage and can put a charging station in their garage, it's you're going to do. The statistics are 80% of the people do most of their charging at home. Well, if you have a home that accommodates that, that's great. But there are 30% of Canadians that live in, multi-unit rental buildings. And, that's a different proposition to try and get chargers in those. So, what we really need is the regulations to be updated to ensure that, anytime builders are building new condos, new MURBs, what have you, that part of the building requirement is that you at least build in the capability to put charging stations into those units, because it's way easier to put the units in once you have the carve out done in to ensure that the stations can be deployed in the buildings than trying to retrofit them after the fact.
Do you think it should be up to the manufacturers to create the infrastructure? When you look at Tesla, they have the Tesla superchargers. There's the Volkswagens of the world, and there's the other Honda and Toyota. I guess when you look at it, when you have the Essos and the Petro-Canada, they don't have their own make and models of cars. So I guess throwing it out there, do you think that there should be maybe universal charging, and should it be up to the manufacturer to work, with these?
Yeah, I mean, and you raised Tesla, and Tesla's an interesting example, because if you look at their whole business model was predicated, they were a new new car company. Their only product is electric vehicles. So for their business model to work, they need to have they absolutely need to build out their own infrastructure. They weren't saying to government, "Oh, well, we're building an electric car, but you build out the infrastructure for us." But I think for traditional automakers that are involved in this transition, it's hugely capitally expensive to make that transition, to build the vehicles, to build the batteries to support the vehicles. That by and large, manufacturers don't look at it as their job to put the infrastructure in place as well. You have seen some exceptions to that. So Volkswagen, for instance, had a ownership stake, I think they still do, in Electrify America and Electrify Canada, which is responsible for building out some infrastructure. It's not their own particular brand per se, like Tesla is, but those stations would be open to any other EV as well. But that's more the exception than the norm. Typically, what happens is that different manufacturers will collaborate with charging station providers, whether it's Flow or ChargePoint or what have you, to say, okay, well, we've struck an agreement with our with a charging station provider. When a consumer buys their vehicle, that they might get a discounted rate or a certain number of kilometers free with their particular charging station provider. But the real challenge is just there's too many different types of charging station providers out right now as well, which would be no problem if they all sort of operated the same way. And you could pay by credit card, but that's not the norm. The norm is that every charging station seems to have a different app that you have to download, and
Exactly.
You need a different card that you might need, so you can have a wallet full of cards.
Need the adapter to go along with it.
Yeah. Some want you to put that deposit down, so that so this sort of thing. So it's certainly not convenient for consumers, the charging infrastructure that we have right now, for sure. And the other challenge that I've experienced myself is just the uptime of the charging infrastructure. There's nothing more frustrating to an EV driver to have 40 kilometers left and go to a fast charger somewhere, only to find out that, oh, gee whiz, it's not working. And then you might be hard pressed to find another station that you can get to with the limited range that you still have on your vehicle. So I know that's something we've been encouraging the federal government and their new contracts, where they're trying to encourage doing RFPs for the installation of charging infrastructure. That part of that RFP would be an uptime requirement, so that these charging stations are maintained, and there is a performance metric built into that contract.
To begin with, we're kind of creatures of habit. We've been driving gasoline vehicles for a long time. We kind of know how it works. We get the idea that we're doing oil changes and where to get gasoline. And it all has a very real level of comfort, because that's sort of the human being part in us. And now you say, well, we'll have these electric cars. Well, okay, how will that be different? How will I charge it, and what have you? So just to begin with, if you get to drive an electric vehicle, you will immediately notice a difference. The performance of the vehicle is different. The quiet of the vehicle is different. It does not feel the same, and it's a really nice feel. There's a lot of electronics in the vehicle that you didn't see in the other ones. But you're right. I went to the corner. I know where the nearest Esso station is in Toronto, and there's no problem. I'll fill my car up. But what am I going to do to get the electricity into this car? And most of the people that started had single family homes and had chargers at home. And that was very common. But you mentioned, and we're moving past that, and we can discuss it later if you have time. But you mentioned level 1, level 2, level 3. This was something that got adopted early on. And I think it's frankly confusing. Mm-hmm. It sounds like, because 1, 2, 3 sounds like okay, better, best.
Right, good, better, best. Right.
But that's not really the truth. So let's break it down for a minute so people can understand. Level 1 is frankly just plugging into a regular outlet. So the regular 120 volt outlet, the same way you plug in your toaster or your vacuum cleaner, that's what it is. Originally, vehicles came with this charger in the car, and you could just plug it in. Not every vehicle anymore comes with that, but they're available. They're not hard to get. And just to give you an idea, so that's charging at about 6 or 7 kilometers an hour. So you say, well, I don't know, that's like not really good. I'll plug it in all night and I'll only regain 60 kilometers of range.
Right.
Well, first of all, you could have a plug-in hybrid that only has 50 kilometers of range. The car sits all night. Maybe it's perfectly fine for you.
Mhm.
Or you went to somebody's cottage and you stayed there for 3 days and never moved the car, in which case it's 60 kilometers. In 3 days, I'll have 180, 200, 250 kilometers. Or even more than that, because it could stay 24 hours a day.
Right.
That might be perfectly satisfactory. So there's a couple of use cases where it could be okay to use. Most people want a little faster charging than that. And this is where we get to this sort of level 2. So both these chargers are taking alternating current, AC current from the plug, and the car itself is transforming it to DC and delivering it to the battery. So that's happening with level 1 and level 2. So level 2 just means now that the charger is at 220 volts. So this would be similar to the feed in your house that might be for your stove or your dryer. That kind of size of feed is feeding it. And now we're getting, depending on what charger we put in, 30, 40, 50 kilometers of range per hour. Okay, so this is already sounding way better. I plug it in and now my 100 or 200 kilometers that I drove yesterday are easily made up overnight, and I have a pretty quick charge. If I came back in the middle of the day, sat for a few hours, I might pick up enough to sort of manage the rest of the range. And frankly, it's just a great overnight charge. If I'm home for 8 or 10 hours, even a pretty big battery, my car has almost 600 kilometers of range. So not that I use 600 in a day, but if I use 300 or 400, it'll easily make it up overnight. That's pretty typical of what goes into a single family house, and the cost is not extreme. The chargers, a whole installation with the chargers, maybe $1,500, $2,000. They're not all the same, but you get an idea. So that's pretty easy. If you have home charging, you're pretty much, and a decent range on your car, you're pretty much set for everything you do in general. But let's assume that I'm going to come to visit you, or I want to go to maybe something a little more typical. I visit my brother in Ottawa, so that's a 4.5, 5 hour drive. My car that I have now could pretty much almost make it all the way. But the car that I had before had about 350 kilometers of range. I needed to make a stop. That's where I stopped at a DC fast charge or a level 3. This is what level 3 is.
Right.
So these are these bigger chargers that we see by the side of the road, maybe the size of a refrigerator, or the Tesla chargers that you're used to seeing.
Charger, a supercharger. Yeah. Tesla.
Yep, exactly. All these words you're using are Flow is a manufacturer and an operator. And these are all DC fast chargers. So the difference there is the energy is delivered in direct current directly to the battery much faster, and I may make up 300 or 400 kilometers of range in maybe 45 minutes or a half an hour. So people would use those as their driving places, but even people that don't have home charging now, I'm finding that sometimes they're using these. So they're working it into their schedule to sit for maybe half an hour once or twice a week, and they seem to be managing. I don't think it's yet ideal, but it's a stepping stone. We're kind of, part way there, and it gives people the ability. I frankly, when I got my first car, that would have been about 7 or 8 years ago. This would have been unthinkable. There just weren't enough chargers around to even consider doing this. And even going to Ottawa, I had to stop in Kingston because there wasn't anywhere really else to stop. And it worked out fine. And we had lunch, and it was a whole event. Now I'll sometimes stop for 10 or 15 minutes, grab an ice cream or go to the washroom. And that's enough for me to easily, comfortably make it my way to Ottawa. And then when I'm in Ottawa, I'll deal with how I'm going to charge there for the return trip. So that gives you, that's the level 1, 2, 3. So think about it, very slow, kind of the average charger. And even the level 2 chargers come anywhere from about 16 amps up to about 80 amps. We use them for fleets as well, because at 80 amp, that's kind of the lower level for a DC fast charger. So, okay, I think I'd see if you can consume all that information.
Yeah, well, one would think that level 1 would be the best one, but it's
Oh,
not.
really?
You flip it around, right?
But I don't look at it as being best or better. They are suiting a particular need. It fits fine, but get the right for us here. We want to hear what your situation is, and then we'll find the right solution. So, frankly, again, if you had a small battery and you said, I'll just plug it into the garage, it's fine. If you want to put sometimes when my daughter comes to my house, they'll plug into one of my chargers and we'll go to the park and whatever. In a couple of hours, her car's topped up and she's thrilled. Right. So, she's using opportunity charging. She has no charging at home. She lives in an apartment building and she uses chargers both at her work and her husband's work, and they don't drive more than about 50 kilometers. And she told me last week that for the first time, 2 weeks had gone by, she didn't put gas in the car. So she was very excited. This is very typical of these people with the plug-in hybrids to have a sort of a game to see how they can manage not to put gas in their car.
Oh, yeah.
And it's a bit of a stepping stone. If you can manage with 50, you think at some point, well, if I had 350, oh my God, I could manage perfectly fine. So, I'm not against these plug-in hybrids as a stepping stone to sort of work towards all electric.
Well, as an EV driver myself, I find it makes me a smarter driver. I think a little bit more instead of just getting in the car and driving. You're just thinking a little bit more about the drive. You're actually enjoying a little bit more of your surroundings, because if you have to stop, for 10 minutes or 30 minutes to charge the car, you're taking advantage. You're slowing down a little bit. You're kind of enjoying the drive. It's a different philosophy that it took a real shift, but now I love it.
Yeah, it was very interesting. When I first went to get the car, I thought, okay, well, how many kilometers do I drive in a day? If you'd asked me, I had no idea.
Exactly.
I had to spend a week or two figuring out whether this was making any sense or not. And there was a whole bunch of things that I had to go through in my mind. I think it's a little easier now than it was 7 or 8 years ago. But I didn't. And when I explained to non-EV drivers, they ask, how long does it take to fill the whole battery? I said, when's the last time you drove 600 kilometers in one day? Right? You and I know, right? We have exactly what you're saying. We have a slightly different way of thinking, and it takes time to figure this out, right?
Yeah, and once you get past that, then you're really enjoying it. It's the journey and the destination, I guess, you're enjoying. You're doing some really great things at UNB. And tell us a little bit about your research and what led you to where you are now.
Sure. My research mainly focuses on making wireless electrified roadways a reality. So the idea being the roadway in the province, for example, highways or sections of city roads could be retrofitted with basically wireless charging. Wireless chargers, I guess, is the best way to put it. The idea being you drive over that and power is transferred through the road to your vehicle, and at the very least reduces the amount of energy that your vehicle needs to consume to move. And best case scenario, it's topping up your battery as you're driving. And I guess a little background for myself. So I'm from this region. I was the East Coast, I guess, born in Halifax and raised in Fredericton. I did all my education at the University of New Brunswick. Around 2014, I received my PhD, went out and did an industrial postdoc with a small company in Newfoundland for 2 years. And then I was lucky enough to join Solus Power, which is a Newfoundland tech company that develops capacitive wireless power transfer technology. And I just found that incredibly interesting and really enjoyed. I was there for about 4 years. Really enjoyed my time working with them. But as I got older and got married, wanted to get a house, settled down. I wanted
that happens.
Yeah, I wanted a little bit more of a stable job. The small companies are fun and exciting, but I'm a little bit conservative when it comes to risk and investing in property and everything. So I joined the federal government briefly for 1 year. That wasn't the plan, but that's how it happened. I joined ISED, Innovation, Science, and Economic Development Canada, and my work there was on radio frequency exposure and compliance of primarily wireless power implementations. So I'm still working in this wireless power area, but more on the regulatory side. How do we make sure the technology is deployed in a safe and responsible manner?
Mm-hmm.
But about a year in, I got the offer to come join UNB as a faculty member, and well, I loved my work at ISED. It was just too good of an opportunity to pass up. So been with UNB since 2021, and I'm kind of combining those past experiences on the regulatory side and then the tech company side to develop these electrified roadways at a more of an academic research and demonstrator level, focusing primarily on this capacitive power transfer implementation.
Well, speaking about that, the wireless transfer, how does this technology work? I have an EV.
Right.
I mean, my ears perked up as soon as I heard that, the wireless charging bit. So how does it all work?
Sure. Well, I'll do a little step back and just talk about electric roads in general, because wireless is only one solution that's being looked at right now. So the whole idea with electrified road is of course power is transferred to your vehicle while you're on the road. And there are kind of three solutions. Probably the most established solution are overhead lines. So sometimes you see in cities there are bus routes where there are, say, two overhead lines, and the bus is kind of grabbing those lines as it's going along, and power is being transferred to the primarily electric bus through those overhead lines.
Yeah, right.
And that's probably the most established implementation, but it's pretty limited. It's not very flexible. So maybe we could do heavy duty vehicles like transport trucks and buses that way, but passenger vehicles or vehicles with dramatically different heights would struggle. The other contact-based solution is ground rails. So basically, in the roadway, instead of those two overhead lines, you just embed the lines in the roadway, and your car, a little, contact flap goes down and physically touches those rails as you're driving, and you charge up that way. So those are both a little bit more established, but of course, the fact that you have that physical connection creates maybe additional points of failure, and is a little bit more. At least electrical engineers, we always like to avoid any kind of mechanical wear and tear as much as possible.
Yeah, more cumbersome.
Right. So the wireless power transfer side is basically there's no physical contact between the two. So we have these two circuits: the circuit that's in the road and the circuit that's in your vehicle, and they're coupled through either electric or magnetic fields. By far the most mature implementation right now is using magnetic fields, so what we call inductive power transfer. And it works very much like the transformers that you see for power distribution. I know not everyone knows how those work, but you might see the cans on your power lines every once in a while. They blow up in a very exciting manner.
Right.
And these are basically just coils of wire that are very tightly coupled. So two circuits that are physically separate, but the magnetic fields pass through both coils and couple them together, and it's very useful for power distribution for a variety of reasons.
So that's how people would fully charge their cars as they're driving along, through these coils, wireless.
Right. So the idea here is they're much less coupled.
Yeah.
There's a big air gap between them, so we have to do all kinds of things it's not a new idea at all. This is like Nikola Tesla turn of the 20th century kind of idea, but the technology to do the power transfer efficiently over that big air gap just hasn't been there until recently. So we work at higher frequencies, and everything's tuned up really, really carefully to maximize efficiency, so we can get that power transferred. And yeah, the idea is you're driving along, there's a coil in the road that gets energized, and it excites the coil in your car. Electricity flows through that coil, and then you just convert it to whatever voltage and current levels are needed to top.
That was a look back at just a few of the bright minds reimagining how we move. If this episode sparked an idea or raised a question, we'd love to hear from you. Thanks again to the province of Nova Scotia and the Smart Energy event for supporting this podcast. I'm your host, Maria McGowan. Thanks for listening and see you next time.